Hello and welcome. Hello and welcome. Hello and welcome. Hello. Okay, welcome. Okay, we are live. We are recording. Of course, I'm going to edit that part out. I'm going to edit this whole part out. In this video, I kind of want to do something different than I normally do. I normally just solve a bunch of math problems, but in this video, I actually want to explain. So I wanted to do a video or a series of videos. So what I want to try to do in this video is, what I'm going to do with these videos is show you how to work out these problems, basically go through the background information of why all this stuff is happening and blah, 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 whatever, who cares, okay. What do we have to multiply x by to get 3x squared? Well, the answer to that would be 3x. Do a little tic-tac-toe here. If that's 3x, we have to multiply 3x by 4 to get this term. Let's combine our like terms in the middle. So this is actually 3x squared plus 6 plus 1m is 7m plus 2m squared. Okay, two more square root equations. So here's what we can do. Square root negative 9, let's split it up using this property. Let's split it up into two of its factors. And I'm going to pick 9 times negative 1. Now, why did I pick those numbers? Well, I picked the negative 1 because I do know the square root of negative 1. It's this weird number called I. So those will cancel. And you're left with the square root of x plus 1 is equal to 2. 4 divided by 2 is 2. Now that we have the radical isolated, we can raise to the second power. So raise both sides to the second. 2x times 3x gives me 6x squared. And then 2x times 2 is just 4x. Positive. We are studying what's called the principal square root function. That means every number only has a positive square root, not a negative. The square root of 4 in this case is positive 2. Not negative 2. That is, it's actually a function. You could say this is a function of x, which gives the area given any value for x. Well, now, why do we use principal square root? Because if you looked at all the results, you say the square root of 4 is positive 2 or negative 2, then we would get something that is not a function. That would break what's normally known as the vertical line test. We were to graph out the negative part as well. There is a lot of stuff to know. Since 9 is a perfect square, its square root is a whole number. The domain and range for any odd-powered radical function, the domain and the range are both the same. They are all real numbers. 6n as your coefficient for your middle term. And then the last term is just n times n, which is n squared. Two solutions for the system are negative 1, negative 3, as well as 3, 5. And the constant term, well, we already knew the constant term, it was 32. So we have all the values that we need, basically just from this equation. So what this tells me is because those two are equal, that their coefficients all have to correspond. They all have to be equal. In other words, let me color code this for a sec. 6n, that value, is the same as k, since they're in the same positions. N squared has the same value as 36. Let's take that, because that gives us an actual value for n. If n squared is 36, take the square root of both sides, so n must be equal to positive 6. And it's only positive 6 because of this. N is greater than 0. N can't be a negative number. We need to highlight some key information. Let me color code this for a sec. So, the length L, 5 centimeters more than twice the width. A rocket is fired in the air from the ground. It reaches a maximum height of 320 after 8 seconds passed. Height is 320. That's actually your vertex, because maximum. This is what your parabola should look like, approximately. Distribute that and you go 2w squared plus, and it's 5 times w equals 18. That might look like a strange equation to solve if you're not familiar with quadratics. What's funny about this is when you square both sides, you end up with a quadratic. You have to take note of that because it may or may not have two solutions. This one actually does. So there are two possible solutions for this equation. There's two things you could plug in here that would work. But here's the thing, we're dealing with area. This is a geometry problem. Any sort of length, width, or area, those values can't be negative. It wouldn't make any sense. So this solution, even though it's valid, we have to reject it in terms of the word problem. Reject this solution. So x is 2, that means w has to be equal to 2. The vertex then is r squared, that's x and y. So my height is r squared. Therefore, the area of that triangle is given by 1/2 the base, and the base is not r, it's actually 2r, since r was just half, times the height. You do start to see a pattern emerging here. These are getting less and less every time. That's going to continue, because when you add a number inside parentheses, you're always going to shift your graph to the left. So we're going to get a series of graphs that look a little below the x-axis. They look something like this. And we just need to find the sum of all these x-intercepts. 1/2 times 2 cancels. Those cancel. So we're left with r times r squared, which gives me r to the 3rd power. The answer is B. If you look at the pattern, it's going to continue that way. So it's going to be -2, this one's going to be -4, -3, -5. If you add all these together, you will get the sum, which is -20. And that's it for the bonus problems. Have fun.